Hi guys, so let's talk about section 8.2, graphing and writing equations of parabolas. This section was really designed for us to do in class together with some inquiry that you're doing together as a group and trying to come up with stuff by yourself. But unfortunately, since we're not together, we can't really do that. So I'm going to go through and do the first example for you. It's not really an example, it's more of like a derivation of a formula. And then you should really try and do the second part by yourself. So this whole second part of the example, I'm not going to do for you, okay? Or second part of the example, second formula that you have to derive. I'm not going to do that for you. I really want you to do that by yourself. The completed note sheet is posted on Schoology for you, but I think you should try and do it yourself first and then see if you can come up with the correct formula and then check yourself to see if you're right. Okay, and this second example or this second derivation here, you can do that just in exactly the same way as we did the first one, except things are switched around a little bit because this parabola opens vertically, as you can see, and this parabola opens horizontally, as you can see. So things are a little bit switched around, but you should be able to make the connection and hopefully understand the concept. Okay. So in this section, we're talking about parabolas in more depth than we have in the past. In the past, we just said y equals x squared is the parent function, and we graphed the parabolas. In this case, we're going to look at it using the classical definition from a conic section sense. This has been around since 300 BC. And if you looked at Schoology at all, and you looked at the resources I posted there about Apollonius, the father of the conic sections, he basically came up with what we're doing here like 300 years before Christ. Okay, but this comes from an understanding of a cone. If you cut a cone in a specific way, you get a parabola. If you cut a cone parallel to one of the sides of the cone, you get a parabola. Okay, and if you look at the picture on Schoology that I posted for you, it's also shown and demonstrated there. Okay, and so we're going to use this classic definition to do the derivation of the formula. So let me just jump in. It says by definition on any parabola, so if this is my parabola right here, okay, this is my parabola, on any parabola, okay, each point xy, so we just picked one, any point xy, is equidistant, which means the same distance from a point called the focus right here and a line called the directrix. So the line here is called the directrix, okay? And we're saying if I pick any point, it's the same distance from the focus. This distance here is the same as the distance that it is away from the directrix. And when I make this tick mark, I mean the whole distance here is equal to the whole distance here, okay? So that's the classic definition of a parabola. Now we're going to use that, and I mean technically also what we've done here is we've used the correct terminology for our formula that we want to see, and that is we called this little distance here from the vertex, which in this case, please notice the vertex is 0, 0. For everything in this section, our vertex, for every parabola in this section, our vertex is the origin, which is 0, 0. We've chosen a specific letter P here to show the distance from the vertex to the focus and the distance from the vertex to the directrix. Okay, we call that distance P. And that P is important. It will make our formula turn out correctly in the end. So we want to derive the formula. Okay, so let's try and derive the formula. We're going to use some logic. Now, you can see that we've added a triangle in here. This is not at all necessarily obvious, but we've done it for you to try and help you do this when you were doing this in a group activity without my help. And so we can use this information. It says use the Pythagorean theorem. We can find the length of segment D. So my triangle is, and I'm going to erase this blue part here. My triangle basically is this side and this side and this side. Okay, those are my three sides of my right triangle. And it's important it's a right triangle, so we can use Pythagorean theorem. So all I have to do is say this side here is, and D here means the length of the side, so D squared equals the length of this side. Now this is not difficult because if the x-coordinate of this point is x, then the distance from here to here is x. So this is just x, okay? That's x squared plus, and then the question is, what is this distance right here? Now, let me show you if this distance here, we don't know what it is directly, but we do know that this coordinate again is y, okay? The y coordinate of this point is y. So I know that the distance from the x-axis all the way up to here, that distance is y, all right? But I'm looking for the length of the leg, which is this distance. So if I say, it looks like if I take that y and I just chop a piece off of it, if I chop this little piece off, then I get the same distance, okay, the same length as the leg of the right triangle. But what did I just chop off to get that same distance? Well, that's p, okay, p. We'll go back here, this distance is p. So if I take p away from y, then I get this length. So this is y minus p. Okay, so this is y minus p squared. All right, so that's just basic Pythagorean theorem. And then we can maybe just take the square root of both sides and say d is equals to the square root of x squared plus y minus p squared. Okay. All right, and then there's some more guidance here. Considering the vertical segment length of d, we can also see that the length of the segment d is and something else. I can express it in a different way. Okay, so what we've done is we've taken this segment d and expressed it in terms of Pythagorean theorem down here. All right, now let me erase all of this stuff and let's look at just this segment d and express that in a different way. All right, so how long is that segment d? Well, we just said that the distance from here to the x-axis, this distance is y, because that's the y coordinate. Okay, the y coordinate is y, so the distance from the x-axis to that point must be y. Plus a little bit, you can see that the d, the length of segment d, has this little extra piece. This little extra piece. But what's the little extra piece? Well, again, that's p. Okay, that's p. So if I say y plus p, I get the length of the segment d here. Okay, so I can say d equals y plus p. All right, and now I have two things that involve d. And so I can take this and substitute it in there for d. Okay, so y plus p equals the square root of x squared plus y minus p squared. And this is good. Okay, and so now all we need to do is simplify this equation and see what happens. Just try and simplify things and add things together and see what we come up with. And you'll see that magically the equation we're after just pops out. Okay, it's pretty amazing. So any case, let's continue. So let's take this and just square both sides. Okay, so let me just square both sides, and what you get is this: y plus p squared equals, and this square and square root cancel, so I just get x squared plus y minus p squared. Okay, and now you just use square binomial formula that you've been doing all over the whole year and square this. So you get y squared plus 2py plus p squared. If you don't remember how to get that, just write it out twice and FOIL, but that's not really good. Your math skills are beyond this at this point. Okay, so you do that, and then on this side I just have x squared, and on this then I have plus, again same thing, y squared minus 2py now plus p squared. That's what I get if I square that. And now we just try and simplify. So if let me do this in different color. If I try and subtract the y squareds and I subtract the p squareds, you'll see that all of those things just go away. They just go away. Okay, so very quickly I'm left with just 2py equals x squared minus 2py. Now this is not the same, this is different. Their signs are opposite, so if I add 2py both sides, I don't cancel them, I actually add them. Okay, so this goes away here, but then I have 4py equals x squared. And I'm going to rearrange this just because I know what the formula is supposed to look like already. Actually, this is the answer. Okay, you have already derived the equation of a parabola and at the same time showing the focus. Okay, P is the distance to the focus from the origin. Okay, or from the vertex of the parabola. All right. And so I'm going to rearrange it just a little bit because I know what it's supposed to look like, and that's x squared equals 4py. Okay, we usually write the square term on its own on the left side, which is different from what we used to do. We used to write it this way, but there was no indication of the focus or directrix. Okay, so there's the formula. We did it. We did it together. Now your task is to go and look at this picture carefully. Very similar idea. I tried to even annotate it even more so that you can get some information from it, and then use that same strategy to just derive the formula. Okay, and what you're supposed to get in the end is this. Okay, that's your goal. That's your goal. But there's a lot of work between the picture and getting to that formula. Okay, if you struggle too much with that, I want you to struggle. Please struggle. The struggle is good. Makes you mathematically stronger, but then you can go look on the completed note sheets on Schoology to see the solution for that. Okay? Alright, so here's a summary then. Assuming that you paused the video and you tried it yourself and did all that stuff, here's the summary of what's going on here. Okay? What's going on here is if a parabola opens up or down, so vertically, in other words, then the equation of the parabola has a x squared term. Okay, x is squared when the parabola opens up or down. Now you should know this because we've been doing this forever, and all our parabolas look like that. Okay, when we had y equals x squared, that's the parent function. So if x is squared, the parabola opens up or down. So again, now we have a formula indicating the focus, which is P, but same principle applies. If x is squared, it opens up or down. And when does it open up? It opens up when P is positive. So when this distance is positive, it opens up, and when this is negative, it opens down. Okay? So when you do some work and you get a negative P, you know the parabola opens down. And if it's positive, it opens up. Or, alternatively, if your formula for your parabola has a y squared in it, then the parabola opens left or right. Y squared parabolas open left or right. And then again, if P is positive, it opens right, and if P is negative, it opens left. So that's what this whole 4 boxes here give you. Okay, that's what that's supposed to show you. All right, so let's jump in and do some. Okay, so we're gonna have 3 things we're doing here: graph some, write some equations, and then solve some problem. Okay, so let's do one. So we look at this equation and we go x equals negative 1/8 y squared. Well, it's got y squared. So I know that the formula that corresponds with this is y squared equals 4px from here. Okay? But that doesn't look like the formula. There's something next to y squared, but I don't want that. See, if you look at the formula, y squared must be by itself. So what you do is you get rid of that 1/8 from the y squared. And how you do that is just to multiply by negative 8. Just multiply both sides by negative 8. Then this cancels, and you get negative 8x equals y squared. Okay? Or y squared equals negative 8x. Now it looks exactly like the formula that we were given. Or actually, that you derived yourself. And so we have y squared equals 4px. Now what this means, the reason I'm writing it like this is because that shows you exactly what to do to find P. All I need to do now is find P, and I can graph it. Because it's y squared, I know it opens left or right, and I just need to find P to know if it opens left or if it opens right. Okay, and so now what this shows me is that I can write this: negative 8 is equals to 4p, because they're in the same place in the formula. okay? And then just divide by 4, and you get negative 2 equals p. So there's p. P is negative 2. So then I know that I'm going from my origin, which is the vertex for this section, for all our parabolas, and I go left 2, and that's my focus, because p is negative. I go left 2, okay? And also the parabola opens left, I know that. And then the directrix would be 2 units the other direction here, so this will be my directrix. Okay, oh, that doesn't look good. This would be my directrix. And please, you should be able to write the equation for this. Your mathematical strength at this point is to the extent that you can at least write the equation. That's x equals 2. Okay, so they say that here. X equals when the directrix is vertical. Y equals when the directrix is horizontal. Okay, and now you know that the parabola looks something like this, but that's not really good enough. Since this is the first time you're doing this, you should probably plot some points just to make a little bit more accurate parabola. So if you just plug in, my suggestion would be take the focus number for x, okay? So negative 2 for x, okay, or the p-value here. Use that as your x value to plug in. And that'll give you usually some easy to graph y values. So just take the equation that we found, okay, y squared equals negative 8x, and this type substitute in negative 2. So you get y squared equals 16, and that means y is plus minus 4. Okay, so when x is negative 2, y is plus minus 4, and that puts me up here, and that puts me down here. Okay, so those are my other 2 points, and then I can draw my parabola. Okay, it's pretty straightforward. All right. Okay, so then let's do another one. This one, y squared equals 4px is the formula if y squared, but this is already the same. So I don't have to change the form or anything. It's already in standard form. I can just say 20 equals 4p, divide by 4, and so 5 equals p. Okay, so now I know y is squared, so it opens left or right, but then p is positive, so it opens to the right, okay, because p is positive. And so I can draw everything I need. Here is my focus, 1, 2, 3, 4, 5. P is 5, that's my focus. That means my directrix goes in the opposite way at negative 5. That's my directrix here. There's my directrix. Okay, here's the vertex of the parabola. And again, now I know because the focus is on the right, it opens this way somewhat, but that's not good enough. I gotta at least plot some points to get a bit of a better feel for what this looks like. So just 2 points. And in this case, it actually means just find one x value. Notice if this was x squared equals 4py, then I would find two y value, plug it in, and get 2 x values. Okay, kind of the other way around. Any case, so you do this and you say take this focus value here, 5, and let x be that, and plug it in here, so you get y squared equals 20 times 5 from the equation in the beginning, and then you get y squared equals 100, and if you take the square root, you get y is plus minus 10. Okay, and so y is plus minus 10 is here and here, and then you can draw your parabola. Okay, so there's that. And remember, you should be able to write the equation for this too. I have to keep saying that. X equals negative 5, right, for the directrix. Okay, so that's how you graph these guys. And then to write an equation is very, very similar. Actually, in my opinion, this is a bit easier, actually. They give you a picture or some information, and you have to write the equation. So to do that, you look at the picture and you go, wait, this is the distance from the vertex to the directrix. That's what they call negative p, or the opposite direction of p. So this must be where the focus is, the same distance. Now just be careful, the 1 unit is 2 blocks here, okay, that's 1 unit. So this distance here is actually 3 over 2, okay. The distance is 3 over 2, the coordinate here would be negative 3 over 2. It's kind of tricky to think about, but okay. So p is 3 over 2, alright. So I know that. I know P is 3 over 2. Positive because the parabola opens up. And then because the parabola opens up, I also know that the equation is an x squared equals 4py equation. So again, looking up here, opens left or right if y is squared, opens left if y squared opens right. Okay, this case it opens up or down, so it's an x squared. So all I have to do is say x squared equals 4 and substitute the 3 over 2 for p. And so I get x squared equals, these two cancel, I get 6y. Okay, there's my equation. The next one, again, as for anything in chapter 8, most math questions, if they don't give you a picture, I would draw a picture just to be safe. Okay, so it says directrix x equals 4. So just go and draw x equals 4. There's x equals 4, and here's the directrix. Okay, this is the directrix. Now we said all our vertices for this section are at 0, 0. And so that means I know that the focus goes the other way. So focus must be here at -4. Okay, so this is my focus, and that's what my parabola would look like, because the focus is always inside the parabola's grasp or arms or whatever you want to call it. Okay, and so in this case, P would be -4 because it goes in the negative direction. The parabola opens left. Okay, so we would say P is -4, which corresponds to the x value of the coordinate of the focus in this case. Okay, and so that's the case, and it opens left, so it's a y squared parabola. Okay, and I just plug stuff in. Y squared equals 4 times -4 times x. So that would say y squared equals -16x. Okay. All right. So those were the basics. Please, I have to just say this to you. You need to know how to do all of this stuff, but you also need to know how to do these two questions. These two are likely to be, one of these are very likely to be on your quiz, okay? Just like I said for the distance and midpoint formula, you need to know how to do those derivations of those formulas. It's the same here. This is not Algebra 1, this is not pre-algebra. We're not just giving you stuff. You need to be able to at least derive some of these formulas on your own. And also then problem solve, which we'll do next. All right, so the next thing is just basically I added this here. The textbook sort of shows you this, but to be honest, I spend in class usually 20, 30 minutes, 40 minutes sometimes going over why are we learning this stuff, motivating this information. Okay, and this is one of my favorite lessons for actually the whole of chapter 8. It's probably my favorite chapter for showing you the incredible accuracy and mysterious nature of math, how math and symbols on a paper can actually match the real world so closely that we actually end up building things using the math, and then it works for us. The physical world works the way that the math dictates. It's really amazing. Okay, so I've said this to you before, but probably the most important application of parabolas are satellites. Okay, and if you look at these pictures down here, they're talking about parabolic reflectors. Okay, now this is not exactly the math we're doing. It's actually harder than the math we're doing because this is three-dimensional. If you look at these objects, they're three-dimensional. Those are called paraboloids. We don't do paraboloids. We're just doing parabolas. Okay, but the cross-section, if I cut this thing in half, you get a parabola. Okay, so the math is similar, but three-dimensional math obviously more complicated. Okay, but if you look at this carefully, it kind of looks like a satellite. It looks like a satellite fell down on its back. Okay, satellite for us is usually like a little arm attached to a dish, and actually, honestly, the focus is a bit off-center usually in a satellite. Looks something like this, and then what happens is signal gets fed in here from the sky satellite, and then they bounce all off into the focus of the satellite dish, and you have a little cable here going into your house giving you the signal for your television. Okay, so if you lived in the States, Dish Network, DirecTV, those are the two major satellite providers. Okay, satellite television providers. People in remote areas get television through satellite, they get internet through satellite. You use GPS on your phone to find yourself, to navigate in your car. People use them for GPS in your car without a phone. All of that technology is based on satellites, being able to find out where you are, position you, the whole works. It's huge, huge, huge. So satellites use the underlying concept of a focus, okay, a focus in relation to the parabola to operate. Okay, so satellites are one, and then the other one would be what would you call this? Something to generate electricity. It's like a solar farm, or to generate. I'll just write here to generate electricity using these parabolic reflectors. Okay, parabolic reflectors. Okay, which again, it looks almost exactly the same. And please, if you're going to Schoology, I spend a lot of time putting resources for you in Schoology about this stuff. You can watch videos, you can see pictures, all kinds of things. I have a huge picture of, well, not a huge picture, a few pictures of a huge solar farm. They call it a solar farm, a farm. You're farming sunlight basically to turn it into electricity in Nevada. Okay, it's very, very cool, very interesting that we're using parabolas to basically generate electricity now too. Okay, some people use it to heat water. If you go to developing nations, a lot of them have parabolic shape thing on their roof with a pipe, and it's heating water for them. So they have a water heater, okay, with just sunlight with no electricity. And then the other one, that's more fun, that you may have seen depending on where you lived in the States, is a solar cooker. You can actually use the sun's rays to heat food without any electricity. Okay, it's like a barbecue without you having to make the fire. And so people buy a solar cooker, and what you do is you just put your pot with your food here in the focus, and then the sunbeams come in and they reflect off the dish, and they all focus on the focus, hence it's called focus, and they heat your food, and it's amazing. Okay, so solar cooker, free food cooked without any electricity. Okay, so, and it all relies on this concept of the underlying mathematics of a focus and a parabola. All right. Okay, so please, you need to know how. Definitely need to know to be able to explain that to me on a test. Okay, definitely need to be able to explain why do we learn this stuff in the first place. And if you take some time, it makes the math much more interesting if you see that it's actually heavily used. It's probably the most applied thing we do all year is this. This is amazing. Okay. All right. So then, example 6, which is actually example 3. I apologize. Is an example of this. Okay, it's called the Eurodish. Was developed to provide electricity in remote areas. Okay, and it uses parabolic reflector to concentrate sunlight onto an engine to generate electricity. Okay, and so this is actually very big. If you look at this, it's very, very big. But the question is this: write an equation for its cross section, the Eurodish's cross section. So what does that mean? It means if I slice this dish in half, what does it look like from the side? Okay, and that's this. It's this. All right, that's that. So that is a parabola. It's a very flat, narrow parabola, but it is a parabola. And this would be. It says the engine is located at the reflector's focus. So this is the focus right here. Okay, so the sunbeams come in here and they reflect back there, and they heat up the helium, and that generates electricity. Okay, so that's that. So this is the information they gave you. So basically what they told you then is that P is 4.5. Parabola opens up and P is 4.5. That's what they told you. Okay, so you just have to write the equation. And we're considering this as the vertex. So we're considering the vertex here to be 0, 0. Okay, and so now we can just write the equation, and we'll say this would be x squared equals 4py because it opens up, so it's an x squared parabola. And we can just plug in our 4.5 for p. And then you get from that 18y. So we now have an equation for this parabola. This parabola's equation is x squared equals 18y. That satisfies every point on that parabola. Okay? The next question is harder, and you really should take some time. You should probably pause the video and try and solve this yourself. It's not that simple. It's actually a bit harder. A lot of students get stuck on this, and we end up helping them in class, or friends help them, or they help themselves with their friends or whatever. Okay? You really should try and struggle on your own and try and solve it, and then if you can't do it, then come back and look at the solution. Alright? So, assuming you did that, you tried it on your own, I'll go over the solution. Okay? So the question now here is, how deep is the dish? And a lot of students don't even know what that means. How deep is the dish? So, if I superimpose, so we can think of this as the y-axis, okay, and if I superimpose on here the x-axis, okay, the question they're asking, how deep is the dish, is this. This is the depth, okay. This is what they're asking. How far is that distance? How deep is the dish? All right. So what you can do is think about this way and say, oh, let me call this coordinate here xy, okay, and then try and solve it and see if I can come up with anything. Now remember, I have an equation for the whole parabola here, okay, so if I can find an x or a y, I can just plug them straight in there. Now I can't use p, this is not on the parabola, this is the focus, it's inside the parabola, so that doesn't work, okay. But actually they've given us some extra information up here. They said that the distance from here to here, this distance here is 8.5 meters. Okay, and if you look at the picture carefully, we know that the axis of symmetry is the y-axis. So then I know that this distance from here to here is a half of 8.5. Okay, and a half of 8.5 is 4.25. All right. So that tells me that actually this x-coordinate, the distance from here to the x-coordinate, okay, that point is 4.25. And all I really need to find is, if this is the coordinate, if this is the point, then I just need to find how high is this value, but that's equal to the y-coordinate. Okay, so all you have to do is take your x-coordinate and plug it into the equation. Okay, so you just say the x-coordinate of that point is 4.25 squared equals 18y. And if I do that and I solve it, I get the y-coordinate for that point. And that shows me the depth of the dish. And so if you do this, you get 18.0625, I think is right, equals 18y. And if you do the division, you just get 1.003. Okay, so that tells me that, let me go back to the picture, the y-coordinate here is 1.003, or the depth of the dish is 1.003 meters. Okay, so for us this means meters. It's all in meters. All right. Okay guys, I hope that was good for you. Have a nice day.